Uh, hello. Hello, how are y'all doing? Welcome to our Wednesday class. I'm sorry I was having trouble with Zoom on Monday, so I didn't hold class that day. I kind of felt guilty, but then I thought, oh well, we can just give everyone a break today and have a Monday off. I never called off class or anything along those lines, so I think we should be fine. Okay, so let's go ahead and begin. As always, are there any homework questions that you have from any of the last chapter 5 sections we covered?
Hi, Professor. It's
Hi.
Emmanuel.
Yeah. Hi, Manuel.
I had a question on 5.2, number 4.
5.2, number 4. Okay, let's take a look at that one. So I'm going to go ahead and share my screen. All right, so 5.2, number 4. Okay. Ooh, that one's tricky. It's difficult. Let's see. The instructions read, graph the ellipse by finding the center, vertices, and co-vertices. Also state the location of the foci. Okay. This one is a lot of work because I have to first complete the square and get each one of those in terms of x and y squared. So let's start off by moving that constant. So let's move that minus 16 to the other side by subtracting. Okay, now let's group our x's and our y's together. So for my x's, I have these numbers. They're just that. So I have 8x squared. And then for my y's, you pick a different color, some purple. I have 16 and 64. So I have 16y squared plus 64y. And I have all of that equal to, so far, negative 16. All right, I need to start off by factoring a constant for my y's because I need to make sure I have a y squared. So if I factor 16, I'm left with y squared, and 64 divided by 16 gives us 4. So I have plus 4y, and I'm going to add a number once I complete the square. And that is equal to negative 16. And I'm going to add that number multiplied by that 16. All right, let's go ahead and complete the square. So I take my b. The formula is b over 2 squared. So I have 4 over 2 squared, which gives us 2 squared, which gives us a return of 4. So I'm going to write a 4 for my y's. And now I need to multiply that 4 by 16 before I write it on the outside. So 16 times 4 gives me 64. I'm going to add 64 on the other side of my equation. Okay, all of this was done so I can complete the square for my y's. So I have 16, and that factors to b, it's always a number before you square, y plus 2 squared is equal to 16, negative 16 plus 64, and that gives us 48. And I still have this x here, right? And I didn't have to complete the square because I already have an x squared and there's no other x to consider. So I have 8x squared. Okay, now I want to divide the 48 into each term because I want to make that a 1. So 48 divided by 48 gives us that 1. But now I have to divide 48 to each term. Now it should simplify very nicely. 48 divided by 8 gives us 6. So we have 6x squared. I'm sorry, x squared over 6 plus 48 is divided by 16 evenly. So we have a 3 in the denominator. And we have y plus 2 squared. And this fraction simplified to be 1 over 3. So we have a 3 in the bottom is equal to 1. Because 48 divided by 48 gives us that 1. All right, so let's box this. We have our equation in standard form. Now we can go ahead and start graphing. All right, so pieces that we need for our ellipse. We know we have an ellipse because we have a plus in between. We need our center, which is x has the h and y has a k. Center of hk is 0, comma, -2. And then each one of your denominators tells you a distance, right? So if we want to include our chart here, we have a center of 0, -2. And then right here, we're going to take the square root of 6. Because it's under x, we'll move from left to right because our x moves left and right. And it's going to be a decimal. Square root of 6 is 2.4. So we're going to move 2.4 units to the left and right. So 1, 2, and a bit more. 1, 2, and a bit more. So let's label our points. My center is 0, comma, -2. And then my major axis, because it's a bigger number, is, so I move 2.4 units left and right. So I have 2.4, comma, -2. And -2.4, comma, -2. All right, under my y, I have a 3. And your y-axis moves up and down. So I know up and down, I'm going to move square root of 3 units. Square root of 3 will be a decimal, which is about 1.7. So I'll move up and down 1.7 units. So 1 and a bit more. 1 and a bit more. So somewhere around there. All right, so I have -2 plus 1.7. That gives us -0.3. So it's the 0.0, -3. -2 minus -4. -2 minus -1.7. That gives us -0, comma, -3.7. All right, and that gives us our ellipse. So we can go ahead and graph it. Now, it won't look very much like an ellipse because the points are so close. It would look something like a circle. Now, did we answer our question fully? It wants our center, we did our vertices and co-vertices, or our foci. Okay, our foci for our ellipse is made up of, what is it made up of? We have it here, larger minus the smaller, right? So foci is made up by c squared from larger minus the smaller one. So 6 minus 3 equals c squared. So c squared is made up by square root of 3, and square root of 3 gives us 1.7. So along our major axis, we're going to move 1.7 units. So I'll do that in red. Oh no, we'll do that in green. 1 and a bit more about here. That would be our foci. All right, I'll interpret that silence as that there isn't any questions, or if you do have any questions on number 4, speak up so we can hear your question.
The over by where it says 16, and then parentheses y squared plus 4y plus 4.
Uh-huh.
So in the bottom it says 6/2. How did you get 6/2 again?
Oh, that was a B.
6/2, and then 4/2, and then
That's a B.
yeah. Oh, okay.
I was like, I don't know, how did I get 6/2? Oh, it's a B.
My bad.
It's okay. Are there any other homework questions from chapter 5?
On 5.3, number 4 and number 6.
5.3. Number 4, number 6. Gotcha. All right, so same idea. We have to complete the square for this problem. Now, because it's 5.4, we know it's not going to be a circle or an ellipse. We know it's going to be a hyperbola. But another thing lets us know we're going to have a hyperbola is because we have a minus on one of the variables that's squared. So we're going to start the same way. We're going to move our constant, so minus 16 and minus 16. And then we want to group our y's and our x's together. So for our x's, we just have that 5x squared. And for my y's, let's see what we have for our y's. I have a minus 16y squared plus 64y is equal to negative 16. So we just have those y's there. And we make sure they're next to each other so we can complete the square. All right, let's go ahead and complete the square. So I want to factor that negative 16 so we can work with the completing the square portion. So our b is 64, and we have b over 2 squared as our formula. Okay, let's go ahead and work that out. So we have 64 divided by 2, and then we're going to square it. 64 divided by 2 gives us 32. And if we square it, that gives us, well, that's a really big number. All right. So we take, oh, I'm sorry. I got ahead of myself. That was a mistake. So I have to factor. So I have y squared plus, or I should say minus, because positive 64 will be divided by negative 16, and the positive divided by negative is a negative. And I have 64 divided by 16. That gives us 4y. And I'm going to add that number to complete the square. So my b is not 64. My b is 4. Negative 4. So I have negative 4 over 2 gives us negative 2. And negative 2 squared gives us negative 4. I'm sorry, positive 4. I write 4. I need to write that also on the other side. And I have to multiply 4 by 16. That gives us 64. So I go ahead and write minus 64. Now I'm just about done completing the square. So let's bring down our 5x squared. I have 5x squared minus 16. And that factored to be y minus 2. Remember, it's always a number before you square. Is equal to negative 16 plus negative 64. You get negative 80. Okay, now we need to make this number equal to number. We need to make that needs to be a 1. The only way to make that a 1 is to divide it by itself. So let's divide by negative 80. Divide each term by a negative 80. Okay, what are we left with? We have to simplify each fraction. Luckily, they usually divide into each other. So 5 over 80, you can divide 80 by 5, and we're left with 16. So I have x squared over 16, but now that one's a negative. And a negative divided by a negative goes a positive. And 80 divided by 16 gives us 5. So this fraction simplifies to be 1 over 5. So I have y minus 2 squared, I forgot the square, over 5 is equal to 1. Okay, now I'm left to rewrite my problem. So I have the minus in the bottom. So that I have y minus 2 squared over 5 minus x squared over 16 is equal to 1. Oh no. Is equal to 1. And this is our equation. Now this was very tricky. Not only was it tricky because we had to complete the square, but it was particularly tricky because we were forced to divide by a negative, and thus we had switched the order of our terms. Okay, let's go ahead and graph this. So some key points, we have to label our center of our little box. So we have a center, and that's h comma k. So we have 0 and positive 2. And then we're going to move up and down according to our y, and our x tells us how far to move left and right. All right, so for our y, we have square root of that 5, since we have it under that y. Punch into your calculator, square root of 5 is 2.2, which is about 2.2. And our x, we take the square root of 16. Square root of 16, which gives us 4. Okay, let's go ahead and make that outline of our box to draw our hyperbolas. So we have a center at 0, 2, positive 2. I'm going to move up and down 2.2 units. So a little bit more than 2, a little bit more than 2. And this now becomes 0, 4.2 and 0, 0.2. And now left and right, we have 4 units. 1, 2, 3, 4. 1, 2, 3, 4. So that's now 4, 2 and negative 4, 2. That gives us an outline for our box. So let's go ahead and draw our box. You want to connect your diagonals. Oh, and maybe something I should start off with. Which way does this hyperbola open? Up or down, up and down, or left and right?
Up and down?
Up and down. Why does it open up and down? It tells you which one it begins with. So because I begin with y, you know you open up and down because your y-axis moves up and down. All right, so let's go ahead and draw our hyperbola. So. All right, so everything we've done is not really our answer. Our answer is what we see in green, our hyperbolas. The rest is just to help us build that figure. Now, one last piece, our foci. Your 2 focus points. Unlike an ellipse, for a hyperbola we're going to add. So it's c squared is equal to a squared plus b squared. All right, so your a and your b are your denominators. So we have 5 plus 16. And that gives us 21. So c squared is equal to 21. We take the square root. So I have c is about square root of 21, gives us 4.6. So along our hyperbola, we're going to move up and down 4.6 from the center. So I have 1, 2, 3, 4, and a bit more. 1, 2, 3, 4, and a bit more. All right. So that gives our foci. So I have a foci of 2 plus 4. So I have 6.6, 0, comma 6.6. And then 2 plus 4, so that's about 2.6, 0, comma negative 2.6. Let me zoom in on that picture so you can easily see those points a bit better. All right, so these are the pieces for our hyperbola. Let's go ahead and take a look at, you also want to see C6?
Yes.
Okay, well, I think so we're going to cover in this section because we're not done with hyperbolas. So for this one, we have to, I think we first have to finish the section. So it's fair that it seems kind of funny. So we'll save that for Monday. And I've updated your homework so that I push some sections over on their due date so that you can still, it wouldn't be marked late if you turned it in. But all your homework is open. All right, let's continue with hyperbolas. We still need to finish that section. So 5.3. Let's see. Let me see where the writing stops. So I think we just barely started graphing. I mean, we barely started going over graphing. And we did some problems. I think we left off the example 4 because that's where I see the writing stopping. And to answer your question, whoever asked the last question, I'm sorry, I didn't see the name. It would lead into this what we covered today, finding the equation of the hyperbola. All right, so let's go ahead and continue with example 4 of your notes. So let's continue with 5.3 notes, example 4. That's a couple of pages in. And it's a lot of what we've done already, right? Completing the square so that we can get our hyperbola in standard form. Example 4 reads, find the center and the direction of the following hyperbola. Opens by converting 4x squared minus 3y squared plus 8x plus 18y minus 11 to standard form. I think we're pros, but I think we can never have enough practice of this. Particularly, I remember I'd never liked completing the square when I was like going through school, but now I really enjoy it. I feel like it's something that, you know, it's challenging, but it's so worth it at the end because you get so much to get to where you're at. All right, so we know we first have to group your X's and your Y's. If it's helpful, take a moment to label them. So we see that we have X's there, and we have Y's. We'll use a scroll for Y's. We have Y's there. And you think, okay, I need to group my X's and my Y's. And always need to move that constant. So start off by moving that constant to the other side. Okay, now that you've taken the time to group your X's and your Y's, you have to make sure that variable squared is a 1. So I need to factor that leading coefficient if there's any, just like your text reads. However, we cannot complete the square until 1 is the coefficient of x squared and y squared. For this reason, we factor out the leading coefficient, such as we have here. Now with a negative, remember, attach the negative to that whole term. So like the whole negative 3y squared, because that negative can lead you into doing silly mistakes. So be very careful of that. So we have to divide 18 by negative 3 so that we get negative 6. And we need, for our x's, we need to divide everything by a 4. All right, now that we have that, we can go ahead and complete the square. Label your b. Your b is always that number that's next to your variable not squared. So that would be our b. So for our x's, if I divide it by 2 and square it, we're left with 1. So I'm going to add a 1 and multiply it by the outside. So I know to add a 4. 1 times 4. For our y's, we have that 6 divided by 2 squared, which gives us negative 3 squared. So we're going to add a 9. So plus 9. Remember to ask for permission to see if you can go out, because otherwise you can't go out because of ethnic rules. So that you get 3 times 9, 27. And we have this word highlighted here in red. All right, factoring twice on the left side and combining the values on the right side, we get here once you combine like terms. Did I hear a question or somebody's mic?
Yes, Ms. Bakari, how did we get when you factored out the 4 from the x's? How did you get a negative 2?
That's typo should have been a plus 2. So that should be, the equation has a plus 8x. So this should be pluses. All of those should be pluses. So this should be in plus. So our whole problem is wrong. Well, not wrong, our center is wrong, and thus everything else is shifted. But yeah, thank you for catching that. All right. So we have a center at -1, 3. Right. Okay, let's move forward. Finding the equation of a hyperbola. Now I don't mean to cut that problem short, but I think we got practice of doing those type of problems in our homework. And we can totally live without another example of that. All right, finding the equation of a hyperbola. The final topic regarding hyperbolas will be questions that start with given information about the graph of a hyperbola while asking us to find the equation. Example 5, finding the equation in standard form of the hyperbola with vertices 0 and plus or minus 6, and the foci at 0 and plus or minus 10. So this, when I read this question, just for example, just like you, whenever I see a lot of words in a math problem, I kind of get turned off, right? So first time I read it, I'm like, oh no, one of those problems. And I have to read a couple more times. So I know when I teach, I kind of rush through these problems, but if I were doing this as a student, I would read like a good five or plus more times through, just so the first time, just to get over the fact that it's a word problem, start digesting it, and so on. So I need to work with a hyperbola. Okay, I know what that is. And it has these vertices. So to start off, why don't you sketch? And it even tells you here, you can sketch what you have so far, right? So we have our vertices, which is essentially like the vertex of your parabola. And I'm labeling them. I'm drawing them a bit darker so you can see where those points are. And your foci, remember that's that extra point that goes forward inside your parabola. So those are those points in in green. Okay, so with that alone, we know our parabola that we see in red, we know it opens up and down. Because those are the points that can have that would lead us to a foci along our y-axis with those vertices. Okay, in order to graph this or to find the formula, all right, so it starts with a y, it would be y with some center squared minus x minus my h squared. I need to have these numbers, right? I need to find what these numbers are. So I need to find the center. I write it in red because I don't know. I need to find my center. I don't know what that is. I also need to find these endpoints. I know what my up and down endpoints are because that give that came from our vertices. So I know because I'm adding plus or minus 6, 6 squared, I know I'm going to have a 36 underneath my y, right? And for your x's, well, we need to do a bit more work. Let's continue reading. Since the hyperbola opens up and down, we are looking for an equation of the form y minus k squared over a squared minus x minus h squared over b squared equals 1. Now, recognizing the midpoint of the two vertices or the two foci gives us a center as 0, 0. Our equation of the form of the hyperbola can be written as, so it just so happens that your center is at 0. But how would you go about it if your center wasn't at 0? Well, you can try counting, but sometimes when I count, I don't know, sometimes I can get it wrong. But I know that if I go ahead and do math, I will not get it wrong. So you can also go about finding your midpoint between those 2 points. So you can go ahead and do some work to find your midpoint. We've done this before in this section. That would be a helpful tool to find that center. You can find the midpoint between 0, 6 and 0, -6. But for this one, what happens at 0, 0? And if you were to count it, this one would work out well. Okay, so we need that last piece. Because our vertices are plus or minus 6, we said we have plus a 36 in the denominator. So what's our other number? All right. The final component left to determine is b. Our sketch above cannot be used to determine the value, but we just determined that a is 6 and the distance from the center is 0 to the foci at plus or minus 10. So c is 10. So we can use the fact that our foci is made up of c squared is equal to a squared plus b squared. So therefore, our a can be 6 and my c can be 10. So I can do a bit more of algebra. Remember, this comes from c squared is equal to a squared plus b squared. And we said a is 6 and c is 10. So this will be 10 squared is equal to 6 squared plus b squared. And that's where those numbers come from, the 136. All right, we do some work. Minus 36, minus 36. So we're left with b squared equals 64. We take the square root, or we don't need to because we want the square one. So we have our b is 8, but we write 64. So this would be our final answer. Because we always write the number square on the bottom. Let's continue with example 6. Find the equation in standard form of the hyperbola with vertices at -1, 2 and 7, 2 and asymptotes with slopes of plus or minus 1. Using the vertices gives a sketch of the hyperbola as follows. All right, so we know our vertices are those points along, it's our vertex. It's our two vertex that make up our two parabola-like figures. So I have these vertex in red, these vertices at -1, 2 and 7, 2. All right, and it also gives a slope of plus or minus 1. Since the hyperbola opens, I think they mean left to right. Opens left to right. We are looking for an equation of the form x minus h squared over a squared minus y minus k squared over b squared equals 1. All right, so to find the center, we can take the midpoint of those 2 points. which is as an option because counting, you can always try counting, but whenever, I don't know, I never get lucky that way. I always have to do that math work. So we find our midpoint between our 2 points, right? So this would be 0.1, 0.1, and 0.2, and find the midpoint of those 2 points. To find your center point. Once you find your midpoint, you have your midpoint formula. You plug in those values, you get the point 3/2, and that would be your center. All right, so we have pieces of our puzzle filled in. We have HK, H comma K. So we write X minus 3 and Y minus 2. Remember, you change the sign. The distance from the center, 3,2, to the vertices is 4 units left and right. So A is 4, giving us the equation X minus 3 squared over 16 minus Y minus 2 squared over B squared is equal to 1. So what's saying here is we know our vertices, right? From here to here, it's 4 units. So therefore, we write a 16. This 4 squared gives us that 16. Finally, recalling the slope of the asymptote of a hyperbola are determined by the ratio of B and A, given the slope of m is equal to plus or minus 1 requires B and A are equal. Therefore, equation of hyperbola is a 16. This is our final answer.
Can you go back up to where you got 16 for A squared?
Yeah. So it's saying that from the midpoint to your vertex, it's 4 units. So that gives you that 16. Now that you know that your center is the point, what did it say it was? 3, 2? 3, 2. Well, 3, 2 to 7, now you know what those points are. You know that that's 4 units away. So if that's 4 units away, therefore it has to be a 16. Remember, when you graph it, you take the square root. To write as an equation, you have to square it. So that's how we get that 16.
Thank you.
You're welcome. All right. The next one, I feel like it's a bit shorter to work with, but it's different. Of course, it's different. The last in our conic section is parabolas. So chapter 5 was conics, and I don't think I talked much about it, but it comes from the idea that if you have a 3D cylinder stacked over another 3D cylinder, if you have a paper or a plane to cut it, all of the different figures you would get would give you a conic, which is this whole chapter 5. So you can run it across, and if it's even, you get your circle. You can make it wider, you get your ellipse. If you run it vertically up and down, you get your hyperbolas. And if you run it to the side, then you have only a parabola. And this is our last section, 5.4, parabolas. Now with parabolas, you have a lot of history. You've done a lot of work with them. But when you work with a parabola written as a conic, it's slightly different, but you still have a U-shaped figure. All right, let's go ahead and begin. Your objectives are 1, the standard form of the equation of parabolas, 2, graphing parabolas, and 3, finding equations of parabolas. Let's begin reading about parabolas. Parabola equations. Previously in this course, we studied parabolic graphs as the graphs of quadratic functions. As the graphs of functions, the vertical line test limited our discussion to parabolas that opened up or down. That's all we know so far. In this section, we will be using a geometric definition while discussing parabolas, resulting in a general definition that follows for a parabola to open in any direction, even diagonally. However, we will limit our discussion to parabolas that can open left, right, up, or down. The definition of parabola is a set of all points in the plane equidistant from a fixed line, called a directrix. A fixed point not on the line called the focus. So in a parabola, say this one opens to the right, that in blue is your parabola. We have these two important features. So we have the directrix in yellow, and we have that focus point in green. This will be an important feature that we have to label in our parabola. As the example above depicts, we will study parabolas using the vertex, directrix, and focus. It's only one focus point, so it's not called a foci or plural. However, despite the general definition, which has no limitation on the directrix, we will limit the directrix to either a vertical or a horizontal line, resulting in parabolas that can open in one of four directions: left, right, up, or down. The list of components involved with a parabola will include the following. One will be your directrix, a vertical or horizontal line. Two, the focus, a point not on the directrix. Your focus, that point is inside the parabola. And your directrix, that one's always outside. Outside the parabola. 3. The vertex is the midpoint of the horizontal segment connecting the focus and the directrix. The vertex is just like before. It's going to be some point H, K. Again, consulting the text, we can derive the following standard equations of a parabola. Y minus k squared equals 4p times x minus h, which opens left or right, and x minus h squared is equal to 4p times y minus k, which opens up or down. So a key tell to know whether it opens up or down or left or right is take a look at your square. Think about what you know. Let's write this on the side. What do you know? What do you know about graphing parabolas? All right, well, we worked on them with y is equal to something, an x squared. When it's x squared, I know it opens up or it can open down, right? So take a look at that bottom one. So with that bottom one, I see my x is being squared. So this one is when it opens up or down. Don't be thrown off. You might want to think differently because of how we work with ellipses and hyperbolas. Now, what are you left with? You haven't worked with y, and that's our new one. So when you have a y squared, it opens left and right. How do you know whether it opens left or right? Well, same way. When you looked at your parabola, how did you know when it opened up or down? You had a negative for when it opened down, and when it opened up, there was an absence of a negative. There was no negative. So same idea. We have to look for that negative and that positive. Moving forward, graphing parabolas. We will focus our initial discussion of graphing parabolas with determining the vertex and the direction in which a given parabola opens. First, when determining the vertex, make sure that the x-coordinate is always the value in the standard equation that is associated with the variable x, while the y-coordinate is always the value associated with the variable y. Secondly, the direction in which the parabola opens depends on two characteristics. We must consider which variable is squared and whether the value p is positive or negative. So that value p that you have above. If you recall our previous study of quadratic functions, the variable squared was x, and the parabola opened up or down. Therefore, equations with the x squared will continue with parabolas that open up or down. Equations with the y squared will be the parabolas that open left or right. Then considering the sign value p, we have the following possibilities. So it kind of guides you. If you have your squared, you know what opens up or down. If your p is positive, it opens up. If it's negative, it opens down. Same thing. For your y's, it opens left to right. If your p is positive, it opens to the right. If your p is negative, it opens to the left. We can now determine the vertex and the direction that the parabola opens using this chart above, along with two standard forms of the equation of the parabola. All right, so here are two standard formulas. And maybe we can write above here, we have our formulas, that if p is negative, it opens, I guess you can write for this one, it opens down. This one can say, if p is negative, it opens left. Just like we have below, but we can have it to each one separately. Example 1. Determine the vertex and direction of each of the following parabolas. All right, so the first thing you want to highlight is think, what variable is being squared? Is it my x or is it my y? Okay, for this one, we see the y is being squared. So we know my options are left and right. Well, I see a negative. So the winner is to the left, right? It's an open left. The equation can be considered in standard form as y minus 0 squared is equal to negative 8 times x minus 0. Remember, we don't have h and k. You can fill it with a 0 if it's helpful. So we have a vertex at 0, 0. Okay, now this part, I don't like how it's worded. The factor of negative 8 is equal to negative 4 gives p equals negative 2. So remember, your formula has this as 4p. So you can do some work on the side. You have that 4p is equal to 8. Oh, well, negative 8. I made a mistake, negative 8. Okay, well, let's find p. You can do so by solving for it. So divide by 4, divide by 4. 4 over 4 is 1. We're left with p is equal to negative 2. And that gives you that same conclusion, in case you don't like to think of it as a factor. So along with the variable y as a squared variable, the graph opens to the left. That's A. Let's go with B. So for B, first thing that catches our eye is where is our square? Our square is with the x. So I know it has to open up or down. Which one do we choose? You see that 4p? Is it negative? No, right? So because it's positive, we're going to choose the one that opens up, not down. All right, moving forward. The equation is written in standard form, giving the vertex as negative 2, 1. Remember, that's hk. And we change the signs, negative 2 and positive 1. The factor of 12 equals 4p gives 3. So just set your 12 equal to 4p. 12 is equal to 4p. Divide by 4, divide by 4. 12 divided by 4 gives us 3. P is equal to 3. So along with the variable x of the square variable, the graph opens up. All right, lastly, see, you can easily point out our vertex, right? So it's always h comma k, and your h is always with your x. And we swap the signs. So I would have a vertex at negative 2 and 3. And we see the square. The square is with the y, so it has to open left and right. I have a positive 6, so it must open to the right. Now I have to find that special value p. So we take 6 and we set it equal to 4p, and we divide by 4 to get p. Those cancel. 6 over 4 is equal to p, but always simplify. So we get 3 over 2. That's our value p. All right, so we just did some basic stuff. Now we're going to put it all together so you can graph. So let's continue reading your text. In general, using the two standard forms of the equation of a parabola, we have y minus k squared is equal to 4p times x minus h, and x minus h squared is equal to 4p times y minus k. We can use the following process for graphing a parabola. First, you want to determine your vertex. Second, determine the value p and the direction the parabola opens. 3, determine the focus and directrix of both a distance of p from the vertex. And determine the width of the parabola and draw the curve. All right, so let's go through these examples. But instead of labeling your your vertex and your value p, we're going to go ahead and graph it. So let's do these problems again from example 1. Our instructions say to graph the following parabolas, labeling the vertex, focus, and directrix. So I have y is equal to negative 8x. We determined that the vertex is at 0, 0, and the graph opens to the left, right? We did that in the beginning with the p of negative 2. So again, in case we forgot, I have my y squared, so that means it opens left or right. Because we have a negative, the winner is to the left. And we get that p from negative 8 is equal to 4p. That gives us that p is equal to negative 2. And we did that in the beginning. All right, now let's add some more. Not starting at the vertex, the focus will be the distance of the absolute value p from the vertex, the same direction as the parabola opens. While the directrix will be the distance from the vertex opposite that direction. Okay, so we have to plot these important figures. And I always get lost here because I'm like, okay, I know my center. We have our center in red. I have my center graphed, but how do I find those other points? In which way do they go again? So in my mind, or very lightly with a pencil, I graph the direction I want. So I know we're gonna go to, you said it opens left. So I very lightly from the vertex, just draw a graph so I can see what I have to do. Okay, inside your parabola, you move the number p units, and that gives you your focus. And then you move away, and that's your directrix. Now your directrix is a line not touching your graph at all. So make sure it's not touching your graph at all. Your directrix is always p units away. Recall that your p, we said our p was what? We had a p of 2. Absolute value, right? So our p is 2. We're going to move 2 units away to find our directrix. And we're going to move 2 units inside to find our focus point, which is what we have in green. Now that's the use of our directrix. So I found some important features, but I still need to graph it. Now I have a very poorly drawn out line in yellow of which way my parabola is supposed to open, just so I can keep track of these p-values that I'm working with. Knowing the graph opens left, the final characteristic to determine the width of the parabola. For the width, we define the segment called the latus rectum. That's a line segment whose endpoints are the parabola from the focus. we find the points a distance of 2 times p up and down from the focus. And it gives us the points -2, 4, and -2 and -4. The endpoints of the lattice rectum. Notice these points are 4 units from the focus and 4 units from the directrix, satisfying the definition of a parabola. All right, so we're going to use that formula, 2 times p. And this will help us find points to finish drawing your parabola. All right, so from our focus, from your focus, you want to count 2 times p. So my p in this case was 2. So I'll move 4 units from my vertex. So I have 1, 2, 3, 4. We have this point here. 1, 2, 3, 4. Which is this point here. And those are the actual points of our parabola. So now we can actually go ahead and draw our parabola. So from our vertex, we go ahead and connect those points. Now you might be thinking, what's all this work about directrix and the focus? It didn't highlight so much here, but it is a distance that is always the same distance from any point along the parabola. And that's a very important feature when you actually apply a parabola into real life. A common thing that I know parabolas are used for are in cars. You know how your cars have this figure and they have a little bulb here? Well, that's your parabola, and it's a special point that makes everything brighter and stronger. And that's how such a small bulb can light so many miles, not miles, but light so much ahead as you're driving. And here we have our finish point. Now, a common mistake I see is that from your, what's it called, your lattice rectum. That's always from your focus. I see sometimes students are tempted to count from your vertex. It's not your vertex. All right, so we have highlighted pieces from our past examples that we did, our example 1. So we had this other bee, and we found from the first example that it has a vertex of -2, 1, and it opens up with a p of 3. And we found that in the beginning of the section. Okay, now let's go ahead and graph these pieces. So I need to use that p, and I need to use it twice, right? We're going to use it twice. We're going to use it for our directrix and for our focus point. And it's always from your center or from your vertex. It's not called the center for a parabola, right? Okay, so I always lose track of what everything means. So I start off with your vertex. All right, we said we have a vertex at, -2, 1. Draw your vertex. We have it right there in red. Okay, and we have a parabola that opens up. All right, draw a silly parabola. Not one that's going to be an answer, but just remember the way things work. Okay, we have our parabola in red set up. Okay, now I'm going to use my value p. And I'm going to move this p inside your parabola. And I'm going to take that p value and move it away from your parabola. that would give you 2 points. When you move inside the parabola, so in this case, our P was 3, right? Our P was 3. We're gonna move 3 points inside. 1, 2, 3, we get that point in red. We're gonna move away. 1, 2, 3, we get our directrix. Now I know we're counting, but we're counting and we're keeping track of our units, right? So -2, 1, move up 3. We're gonna add 3 to our y's, so +3. Well, actually it's right here, +3. To get us to -2, 1 to a -2, 4. We're gonna move away. So 1 gets us a 0, 2 gets us at -1, 3 gets us a -2. We have to draw that dotted line and we have to label it. We have to label everything we do. So that's y equals -2. Okay, now we're left to find some points in my parabola. This sketch that I have in red of a parabola is just so we can keep track of what we're working with. All right, how do we find our points? We use what's called the Lantis rectum, right? So we're gonna use that value, that 2 times P. I know that's very different from all the formulas we work with so far, so make it a point to write down your notes or highlight it in your notes. All right, so we're gonna use 2 times the absolute value of P. And the reason why we use absolute value is because we're not worried about the sign, we're worried about the units, how many units we're gonna move away. So our P was 3, so I have 2 times 3. So from your focus, you're gonna move 3 points to the left and 3 points to the right. So we're gonna add and subtract 3 to our x. So if we add 3, we're left here at 1. So I have the point 1, 4. And if I subtract 3, we're left at -5. -1, 2, 3, 4, 5. That gets us about here. -5, 4. Okay, now we can go ahead and get rid of our little dummy parabola. So you would erase it. And now we can connect our points. Now we connect from our vertex and we connecting our 2 points that we found within our parabola.
Ms. Bakari, would you move 3 points or 6 points?
I'm sorry, I didn't. Oh, 6 points. Thank you. 2 times 3. What is 2 times 3? Well, if you ask your professor, it's 3, right? It should be 6. Thank you. We're gonna add and subtract 6 to our x's. So we have 2, move 4 more. We're about here. Thank you so much. I totally got ahead of myself. And then we add 6 more, so we're 8. 1, 2, 3, 4, 5, 6, 7, 8. And then you connect your points from your vertex to your endpoints of your parabola. There we go. There we go. And it's not so bad. It's just a different way of graphing. But I mean, I feel like it's a lot less complex than an ellipse or a hyperbola for sure. All right, and then you have that prettier computerized answer. For a handwritten one, I think it's just as pretty. All right, let's continue with example 2. So as we move along, we're gonna have the same hiccups that we do with the circle, ellipse, and hyperbola, particularly when it's not in standard form. We have to go through the trouble of getting it into standard form. So let's go ahead and do example 2. Graph the parabola x squared plus 8y plus 8 equals 0, labeling the vertex, focus, directrix, and the endpoints of the lattice rectum. First, we recognize the equation x squared plus 8y plus 8 is equal to 0 can be written in the form So if ever you're working with something, take a moment to write down the formula. What is our formula again? We have it there. Okay. For this formula, you want your squares. You want your squares on one side. In this case, it's your x's. And you want your numbers without a square on the other side. In this case, it's our y's. So let's go ahead and move things around. So your text reads, we can isolate x squared as x squared is equal to negative 8y minus 8. So notice we only have our square and our variables that are attached to it on one side, and everything else is on the other side. If I had more x's, I would keep my x's together. All right, we'll factor out an 8 for our second terms here, our other side, because we want to get y minus a number. We want y by itself. So to get y by itself, I have to divide it by a negative 8. All right, so this is what we have so far. X squared is equal to negative 8 times 5 plus 1. So then from here, we can label our vertex. If you like to, if you need to fill out every piece, you can write that 0, but we can easily see our vertex is 0, 1. Remember, it's h, k, where that h is always with your y, with your x's, and your k is always attached to that y. So keep an eye out for that. The factor of negative 8 equals 4p. So you take this value and you set it equal to 4p. And I like to do the work. So I have negative 8 is equal to 4p. You divide by 4, you get 1. Divide by 4, you get negative 2 is equal to p. So if I want the absolute value of p, it would just be a 2, right? All right, so I have my p is negative 2. So along with the variable x as a squared variable, the graph opens down. So let's take a moment to think, why does it open down again? It opens down because our x is squared, so our options are up and down. Because I have a negative here, that negative makes me choose that it opens down. That's how we come to that conclusion. Let me erase all of that. I know sometimes all my scribbles can be overwhelming. In the same direction from the vertex as a parabola opens, the focus will be 2 units downward, located at 0, minus 2, which gives us negative 2, negative 1. And in the opposite direction and 2 units from the vertex, the directrix will be the horizontal line, y equals 0. So like I said, sometimes it's overwhelming. Start by drawing just your vertex. So we have that vertex there at 0, negative 1. And then draw your dummy graph. Okay, we know we need to move inside our parabola and away. So inside our parabola, we're going to use that p equals 2, and we're going to move 2 units inside, which gives us our focus there. Our focus. And we're going to move away, which gives us our directrix. All right, we're almost done. We need to find that p and count from our vertex. So we have a p of 2. So we're going to add 2 from our focus. So I have a focus of, I'm lying. We're going to use 2 times p. 2 times p, and this is to find more points. From the focus. We're going to count from the focus. All right, so from the focus, you're going to count 4 units. 1, 2, 3, 4. 1, 2, 3, and 4. And we always label everything. So we're going to be adding and subtracting this to our x. And there we have our answer. Let's move into example 3. Graph the parabola 2y squared minus 16x minus 8y plus 40 equals 0, labeling the vertex, focus, directrix, and endpoints of the lattice rectum. Okay, so before even looking at the rest of our work, we know some stuff, right? So I know from the y squared, I know my options are it's going to open left or it's going to open right. Now the rest I don't know. I have to do some work so that I can write it in standard form. If it's helpful, write down what your standard form should look like, right? It should look like y minus k squared is equal to 4p and x minus h. That's what we want. Now, we write the equation because our y is squared, put your y's together. So I want this and our 2y on the same side. Everything else, move it to the other side. So plus 16x, move it to the other side, plus 16x. What else? At 40, move it to the other side, minus 40, minus 40. That way you can get rid of it. So you only have your y's on one side. Okay, let's continue with our text reads. First, we recognize the equation y squared minus 16x minus 4y plus 20 equals 0 can be written in the form y minus k squared is equal to 4p times x minus h. Preparing to complete the square, we isolate the y and the y terms. So we see how we have our y's on one side and everything else is on the other side. Why are our y's the special ones? They're the special ones because that's the letter that has a square.
Did they forget the 2?
Did they forget the 2? No. What happened is that we do not want we don't want a leading coefficient. I didn't emphasize that. We don't want a leading coefficient. So what we do is we can take our whole equation and we can divide it out. So we can divide everything by 2. Now, why can we do this and we couldn't do this before? We couldn't do this before because for an ellipse and for a hyperbola and for a circle, we both have x squares and y squares. They both have the square and they don't have the same number. They have different numbers. So one can have one number and the other one can have another number. So dividing everything to both sides of our equation will not be helpful. But because I only have one number that's square and I need to get rid of that too, I can divide it out to my entire equation. So it saves me the trouble of having to factor and complete the square. So I can just get rid of it. You get rid of it by dividing everything by that 2.
So after we divide everything by that 2, will we still have to, like saying if we're going to put the x's to one side and the y's to the other, would it still be negative 16 or would it be negative 8?
You're right, that should be an 8. So he's saying, hey, well, I did that work, and if I divide this by 2, I get 1. If I divide by 2, I get negative 8. If I divide this by 2, negative 4, this I get 20. And this one wasn't divided, right? So that should be a 8. Thank you for catching that. All right, we still need to complete the square. Why? Because I want to get parentheses squared. So we can do that by completing the square. We take our b, which is negative 4, and we have negative 4 divided by 2 squared, which gives us 4. So we're going to add and subtract 4 to both sides. I'm sorry, we're going to add 4 to both sides. And we have that in red right here. Okay, now we can complete the square. That should be an 8. You know what? To make sure that it's correct, why don't we change our initial problem? Why don't we change that 16? Let's multiply it by 2. That gives us 32, right? Let's change our initial problem, let's change that 36 to a 32. So negative 32. That way we can stay with what's written if we change the initial one, our initial problem. Okay, now it works out. Okay, so now we're here. We're almost there. Now we have some important pieces that we can work with. So I know my parabola opens, my options are left and right because my y is squared. But because we see that my p is positive, I know it's going to open to the right. Opens to the right. No. All right, we have our vertex as h comma k. Your h is always with your x and your k is always with your y. I have to do that every time because I will make that silly mistake of just reading left to right. It's not always left to right. It has a special labeling. So we change the sign so that our vertex is 1, positive 2. And we factor 16 equal to 4p. So let's solve. 16 is equal to 4p. We divide by 4, divide by 4, that's 1. So p is equal to 4. And that's what we have. It gives p equals 4. So along with the variable y as a squared variable, the graph opens to the right. The focus will be 4 units to the right of the vertex at 5, 2. To the left, 4 units of the vertex will have our directrix. So what I like to do again is I like to go ahead and take our vertex and say, okay, which way is our parabola open? We said it opens to the right. Okay, from there I can start labeling points. Okay, so my focus is p units away, so whatever that p is. And my directrix is p units away from your vertex. So we're gonna add 4 units. So we're gonna add 4 units to our x, so 1 plus 4 gives us that 5. 1 minus 4 gives us negative 3, so we have a vertical line at 3. Make sure you write your line, so that's the x equals negative 3. Remember, vertical lines are x equals, and horizontal lines are y equals your number. And the equation of a line is different from your axis. I know everything kind of is mixing up now. So many things to keep track of. All right, and now we have our problem. Lastly, we use our latus rectum, and we multiply 2p to give us how many units to move from our focus. So we have 2 times 4 gives us 8. So we move 2 units up or down from our focus point. So we have a focus point of 5, 2. We move it up and down. So we're gonna go ahead and add 8 units to our y. So 2 plus 8 gives us 8. 2 minus 8 gives us 86. So I have 5, 10 and 5, negative 6. All right, one last piece and we're almost done. Finding the equation of a problem. As with every section in this chapter, the final topic in this section will contain questions that ask for the equation of a graph that has specific qualities. Example 4, find the standard form of the equation of the parabola that has vertex 3, negative 1, and a focus of 0, negative 1. All right, so because it has a focus, a vertex, I'm trying to write, there you go. Because I have a vertex and a focus, and you see how your 1 didn't change? It's always x, y. You see how your y's didn't change, only your x's? So that means we're only moving, if I have this point, your vertex at 3, negative 1, and your focus point at 0, well, like we have them here, at 0, negative 1. And how do I know which way our parabola opens? Well, I know that from your vertex to your focus, it's always inside your parabola, right? So if that's an inside point, then if it can't open up because that wouldn't be inside, it can't open down because that wouldn't be inside from your vertex. And it can't open right because that wouldn't be inside from your vertex. So our only options are if it has to open inside of that, then that would be the only way. So it has to open left. So you can, using the given points, you can sketch your parabola, right? So this is just a sketch. We don't know anything really. We just know our vertex, which is the peak of your parabola, and your focus. But we know some stuff, right? We know that this distance is a special value p. So we're almost there. I know my vertex is h comma k. And I know in my formula I have that number 4p, that special number 4p. And that's about it. That's all I really need. So I need to just figure out what's the distance between 0, 1 and 3, -1. And that's enough to find my parabola. Let's continue reading. Since the parabola opens left, we know that the equation will be of the form y minus k squared equals 4p times x minus h. Given the vertex is 3, -1, our equation becomes y plus 1 squared equals 4p times x minus 3. Lastly, the distance from the vertex to the focus is 3 units. Now, how do we know it's 3 units? Well, we can look at our x's. That's the only one that moved, right? Our x's are 0 to 3. So how many units did I have to move from 0, -1 to 3, -1? It's only 3 units, right? So our p has to equal 3. So like it read, last the distance from the vertex to the focus is 3 units. And since the parabola opens to the left, its p equals -3. Given our equation as y plus 1 squared, and that's that 4p. We plug that in, so we get this final formula. Y plus 1 squared equals -12 times x minus 3. Are there any questions of the examples we just did? Okay, let's continue with the next example. Example 5, find the standard form of the equation of the parabola that has a directrix of -5 and a focus at -2, 1. All right, so let's plot those points. So ignore your parabola and erase it so you're not tempted by it. We could talk about before that existing. Okay, so also what we have right there in yellow and your focus in green, right? Those are the only points we have. Okay, so if we draw a directrix, which is a horizontal line at -5, and if we draw a focus point, then we have to think, okay, well, if that's the case, your focus always opens inside your parabola. So let's give a sketch of what we know so far. And that's what leads you to your parabola, that parabola figure. But we need some important parts that you don't know. You do not know what your vertex is. Now, how can we find our vertex? Well, we know our vertex will be the midpoint from your focus to this point along your directrix. Let's continue. Since the parabola opens up, we know the equation will be of the form x minus h squared equals 4p times y minus k. Knowing the vertex is the midpoint of the vertical segment from the directrix to the focus, we find the vertex is -2, -3, given our equation as x plus 2 squared equals 4p times y plus 3. So what you can do is, you know that it's going to be -2 comma what? Because it lines up with your focus. So what is that what number? What can that be? All right, well, we know we can work with the x values. So if I have a -2 and a -2 comma -1, we work with our y. So we have a -2 comma -1, and if I go all the way to -5, and I use this point -2 comma -5, I can find the midpoint using that, right? So our midpoint formula is x1 plus x2 over 2 and y1 plus y2 over 2. And we can use this point along our directrix. All right, so I have -2 plus -2 over 2 and -1 plus -5 over 2. So that gives us -4 over 2 and -6 over 2, which gives us the point -2 and -3. So that's what this point is left to be. It's the midpoint between these 2 points. Your focus and the point that lines up along your directrix. Okay, lastly, we're left to find P. And we can see the distance from your vertex to your focus point, that only gives us 2 units. So we let that be P. You know that P is going to give us 2. So we plug that in for 4P. We multiply 4 times 2, we get 8. So this gives us our equation of our parabola. And that's it for this section. Now, this section is new. I'm for sure it's new because we've only graphed parabolas one way so far, as a quadratic opening up or down. So it's completely new, but I feel like it's not as complex as the first 3 sections. So I think you'll be fine. And as always, I always post these videos on YouTube, so you have access to them. You can Google search my name, and I post them by our course number and date, so you can easily find your recording that you're looking for. All right, before we take off, are there any general questions for me? All right, well, thank you so much for being here. I'm very happy with the turnout. I'm getting a pretty good turnout, and I'm hoping that those that can't join us live will make sure to check out the recording at some point, or maybe try to just read the notes on their own. But I hope they're following up with the work. And you probably had a chance to make friends to the class, so make sure you reach out to your classmates, send them a text. Hey, how are you doing? Are you doing your work? Just trying to make sure you're doing your work and you finish strong. Now make sure you're keeping up with your work. Don't let it fall. Don't save it to the end and then you're just stuck in a big hole you can't climb out of. So make sure you're doing your work. I have a question in the chat that said, was 5.3 homework due yesterday? No, I changed it to next week because we didn't fully cover it. So 5.3 wasn't due yesterday. I think yesterday the only ones I made due for Tuesday were 5.1 and 5.2. But if for some reason you forgot, just turn it in. It'll just be a bit late. You won't miss too many points. Make sure you turn in all of your homework. All right, before we take off, Andrew, do you have an announcement to make?
Yeah, just letting you guys know we got a SI after class. We switched it on Wednesdays, so now both Monday and Wednesday it'll be after class. It seems to work better for everybody.
Yeah, and I think we remember what we had questions on, right?
Exactly, yeah. And then plus you're already online already, so then you can take a little break and then jump right back into it.
Sounds
But
good.
yeah, so I hope to see you guys there. I sent the message in your Canvas, so it should be there right now. And just click on the link. We'll get it started at 6:45.
Sounds good.
All right.
All right. Well, that's it for today. I'll see you on Monday. Have a nice evening.
Thank you.
You're welcome. Bye, Jessica.
Thank you. Bye.
Bye-bye. Bye, Isaac.